Hello children, I hope you have completed chapter 2 question answer physics. If you have doubt, any tough question is there, you must ask. Okay, now going to start third chapter, that is energy. Children, we have read that a force can move a stationary object. Suppose this is a stationary book, pen. Okay, when I will apply force, then it can move one place to another, right? So when the force applied on a body moves it, work is said to be done by the force on the body. But if the body does not move on applying a force on it, then no work is said to be done by the force on the body. If there is no movement, no work is said to be done, right? So the work done by a force is measured as the product of the force and the distance moved by the body in the direction of force. So you have already learned this in standard 6, that work done equal to force into displacement. Force into distance, displacement means distance moved in the direction of force. And we know that SI unit of force is Newton. 1 joule equal to 1 Newton into 1 meter. So the SI unit would be what? 1 joule equal to 1 Newton meter. SI unit of force is Newton and 1 joule equal to 1 Newton into 1 meter, right? SI unit of work done is 1 joule. Work done SI unit 1 joule. So 1 joule equal to 1 Newton into 1 meter, that is 1 joule, and 1 joule equal to 1 Newton meter. This you need to understand. So 1 joule is defined as the amount of work done when force of 1 Newton displaces a body through 1 meter. Okay, so this is your previous knowledge. So recapitulate our previous knowledge of work done with the help of this simple exercise. Stop and reflect. This you can read and understand properly. A girl singing a song, a boy walking to his school, boys playing football. When you are playing football, children, the ball moves one place to another. It will move in one direction to another direction. Okay, but a man, if you push a wall, a man pushing a wall, or you push a wall, you can try at home. Then you can say work is said to be done. No work is said to be done while you apply a force on it. So no work is said to be done by the force on the body. So that is called no work done. So this type of example you think, you do practically at home. Okay. Now what is energy, children? You have to understand what is energy. So when, just simple example I am giving you, when a girl runs a bicycle to a distance, okay, she spends energy in doing work. Similarly, a boy while playing football runs about all over infield. He spends energy in doing work. So energy is spent in doing work. A boy playing football and a girl cycling. Thus we can define energy as follows. Energy is the capacity of doing work, right? So energy is the capacity of doing work. You can see this figure. When you play or work for a long time, you get tired. This is because when you do work, energy is your body gets used up. In fact, to do work, you need energy. So we can say that energy is the cause and work is the effect. Thus, work and energy are directly related to each other. Right, children? How work and energy are related to each other? So energy is the capacity to do work. Okay. Different forms of energy is there. We will understand one by one. one more example. I am giving you relation between work and energy. So you must have experienced that you can run on a bicycle, or more you run all around the playground, more you feel tired. The reason is that a lot of energy has spent in doing work by you. Thus, to do more amount of work, we need more amount of energy, right children? So hence we can say that there is a direct relation between work and energy. So if a body is moved from the ground to a height, work is done on the body against the force of gravity, and the body at the height is said to possess the energy. Similarly, if a body initially at rest is made to move, work is done on the body, and the body in motion is said to possess the amount of energy equal to the work done on the body. So it is clear children what is energy and units, everything. 1 calorie is equal to 4.186 joule, and it is approximately taking 4.2 joule. So you have to remember this. Maybe ask 1 marks question. Now different forms of energy. There is a very interesting fact about energy, that it can neither be created nor destroyed. Energy can neither be created nor destroyed. Okay, so it can only be converted from one form to another form. So energy exists in many forms in nature. Let's discuss one by one. You can see this picture. A moving car possesses kinetic energy. First you understand mechanical energy, children. What is mechanical energy? The energy possessed by a body due to its state of rest or a state of motion, it is called mechanical. The energy possessed by a body due to its state of rest or state of motion is called mechanical. The mechanical energy is found in two forms, namely potential and energy. Potential and kinetic energy. There are the two forms of energy, mechanical energy. Okay, that is potential and kinetic. So total mechanical energy of a body is the sum of the potential and the kinetic energy. See this picture. Car in motion, arrow on a stretched bow, moving arms of a clock, rock on a high hills. So these are the total mechanical energy of a body is the what? Sum of the potential and the kinetic energy. Okay. Kinetic energy, first you understand. What is kinetic energy? The energy possessed by a body by virtue of its motion is called kinetic energy. Like virtue of its motion means it should be in motion. Like this moving car, it is in motion, it possesses kinetic energy. Moving ball, flowing water, flying bird, running boy, all possesses kinetic energy. In fact, every moving body possesses kinetic energy. If you move your leg and kick a football, it starts moving. That is also kinetic energy. If you throw a stone lightly on a glass window, it may or may not break. But when you strike the stone hard, that is, it is moving fast. So it is definitely breaks the glass. So this is because the fast moving stone carries more energy and is capable of doing more work. So it is clear, children, what is kinetic energy. So the mass kinetic energy depends on the two factor, remember. Okay, mass of the body and the speed of the body. Mass of the body means kinetic energy of a body is directly proportional to its mass. Means the heavier an object, the more its kinetic energy. The heavier the object, the more kinetic energy. And second factor is speed of the body. That is, the kinetic energy of a body is also directly proportional to the speed of the body. This means fast moving object will have more kinetic energy. Fast moving object will have more kinetic energy, and heavier the object, more its kinetic energy. These two factor, remember. So up to here revise, children. Next topic next day. Okay, revise.